What's up, guys? So in this video, we are going to finally take a look at one of the most important, but also if you're coming from sort of artist background like me, one of the most confusing parts of C nodes, which is dealing with arrays. I had mentioned in my last video that I was going to keep doing more procedural modeling stuff, but really, as I was trying to come up with examples, it's getting pretty difficult to do anything that's more complex than what I've already shown without the prerequisite knowledge of at least the basics of dealing with and working with arrays. And I think that if you're really interested in C nodes, it's like this is still really the beginning. Is everything is ultimately going to get to you working with arrays and learning how to manipulate and deal with them. So I made this little example, maybe something like a FUI little setup where we've got these lines kind of dancing around here. Um, a lot of it's a combination of C node stuff and then just like regular cloner stuff. So there's going to be some tips in this video also, like how to get cloner uh, position information into C nodes, a few other little tips and tricks. And at the end of this video, we'll do a full breakdown of this setup. But I think that this is a good sort of spot to end the introduction to learning how to deal with arrays, what they are, and sort of like all that sort of stuff. So let's jump in. And I'm just actually going to jump into a new scene. So if you are, again, if you're even thinking about using scene nodes, then I'm imagining it's not your first day in 3D. So you're probably already somewhat familiar with data types and what a vector is, and maybe you understand that a point in space is a vector, a color RGB is a vector, the index number of the points, those are integers, and all that sort of stuff. um, from my experience, I heard an array. If you would have asked me before I started learning anything about C nodes what an array is, I'd say it's a list of stuff. If we make, let's just make a sphere and press C. And if we look over here at the structure, you can see this is basically an array, right? So you've got point 0 through point whatever, however many points there are, and it's an array of vectors of these points. So these are just the positions in x, y, z. It's 3 values. Vector is 3 values. So that's what I would have said, but I never really had to directly work with. I mean, I guess anything that you do in 3D, you're working with an array. That's the aha surprise. You've been working with them this whole time, sort of thing. But yeah, this is really working with C nodes and learning about it is really my first sort of introduction into directly manipulating this at the sort of like data level. But yeah, that's basically what it is. It's just how the data is stored for geometry, for curves, for particles, for just about everything. It's just all those positions. It's in a list like this. So visually, I'm a visual person. I kind of, whenever, without me trying to, I think of things in kind of like a visual way. And this is kind of how I see arrays in my own brain, which is it's like this series of buckets. And so the individual spots are called elements. And so you've got element 0, and there's a thing in here. element 1, and there's a thing in here, element 2, and there's a thing in here. And that thing can be basically anything. It can be any type of data. It can be a piece of geometry, an integer, a vector, whatever. And it's stored as an array, which is one thing. So it's a bunch of things stored in one thing, and you can, within seed nodes, we can say things like, hey, go grab whatever's in element 4, slot 4, and then we want to do something to it. We could say grab 0 through 5, and then we do something with it. We can say, hey, let's do something to every single element in this array. And that's going to be like the iterate collection. That's saying, hey, do this for every single bucket in the array. So if you're like me and you just like visual stuff, this is kind of how I see it, just like this series of buckets. All right, so let's go back into this new scene and let's just make something. So let's start with kind of the most basic example I can think of. I'm going to make two nulls, and we'll call that one A, and we'll call this one B, and we'll drop both of these in here. And I'm going to right click over here and say add input object child, and I'm going to add two of them because we've got two children. So within here, the position of these two nulls, let's just put them over here. That's going to be this global matrix. So that's basically the position. So in here, if I say build an array, as I said, the array can be any type of data, so we need to specify what kind of data is going to be in this array. So I'm going to say a vector, and I've got two elements because I'm going to make it out of these two guys. So everything within C nodes is helpfully color-coded, and a matrix is actually more than just position. It's the position, rotation, and scale. So that's going to be purple. But if you plug a matrix into a vector, it's going to understand that, yeah, you probably just want the position. So you see it has this little symbol. It looks a little bit different. That's it basically telling you I converted this into the position. So now if we take this one and plug it into here, and now we've got an array that has this position as element 1 and this position as element 2. What can we do with that? We can assemble a spline. Press Q. Oh, no, can't press Q here. Just drag that here. And you see we get a spline. Okay. So another part of this you can think about is that you sort of need a recipe to create different types of stuff. So the recipe for a spline is you need the points, and then the points need an order. So we got the points, and then the order comes from the order in this array. So this is element 1, this is element 2. So if we inspect this, you can see there's 0 and there's 1. So it's a 2 array, or 2 elements in the array. Cool. So that's easy. That's not scary at all. But what else can we do? So another thing that you can do, so let's just say that instead of this null being point A, let's make a platonic, and I'm going to delete that, we're going to make this point A. Still in the same thing. It's because we plugged in the global matrix here. But instead of plugging in the global matrix of point A, let's do a geometry property get, and we're going to plug the geometry into here. So what's going to come out of here is all the points on this platonic. So there's a bunch of different values that are in here. It's the value for each point in here. As you can see, it's another array. Purple squares, that means it's an array of vectors. So if we plug that in here, then we get another node, this iterate collection. I think we need to, okay, so it's just the points, but I moved it over here. Let's not worry about all that. Let's just focus. Let's pretend I didn't move it. Let's just move it back to 0, 0, 0. Okay, so now you can see that point B is connected to every single point in the platonic. And we've got this node that says iterate collection. And so what that's doing is it's saying for every point in this collection, in this array, connect it to point B. So it's the same thing we did before, but it's just saying do it. This basically says do it for every single point. So it's saying go to 0, whatever, 0 through 11. So 12 times, and you can see we get these 12 iterations of that same thing happening. Okay, so that in and of itself is pretty cool, kind of useful. So we can just deal with points and connect one point to a bunch of points. And I think another thing to think about is just like, all right, so again, we're all this stuff that we deal with in 3D, like it's all made out of points. So if you can plug in a piece of geometry right here, so let's go to our let's go here and let's add a new input and let's make an object link right here. So we just added in a piece of geometry right there. So obviously any point of any piece of geometry, you just need this get positions node and that'll work. So what about, let's go to MoGraph and let's make not two, little finger happy, just one. So now we've got a matrix, because a matrix is just a bunch of points too, right? So let's go here and we got our object link and let's drop that in here. And for this one, again, we can grab, I think we want to grab the global matrix. So let's just put that in here. Not the global matrix, just the matrix or the geometry. Wait, no. Is that gonna, there we go, the geometry. So same thing. And you can see we've got all these guys connected here. Let's take the matrix, so it's not so crazy, and spread it out. And you know, you can do all your normal fun MoGraph stuff with this, right? And this is connected here to all these points. So again, what else is made out of points? So we did a piece of geometry, we did a matrix. Let's go to our particles. Let's make an emitter. make a sphere. And let's maybe just do a shot of particles and make them not move so fast so that we just get like a little, let's turn this off for a second. Maybe let's delete this. Boop. Okay, so we get like a little burst of particles. They can actually move faster than that. Let's do that. Boom. There we go. Okay, so let's go in here and grab our particle group and put that in there. And you can see that that works as well. So all the normal dynamic stuff that you would do, let's just add some turbulence. Give ourselves a little bit more time. And we can do fun stuff with that. If we take this now, I'm going to drop this into a null, go to nodes, and let's make an electric spline modifier. We drop that here. So you can do that sort of stuff, these sorts of effects. This is just connecting one point to a bunch of points. It's just a few nodes and pretty easy to understand. So this is basically just saying, hey, get all the point positions for every single point in here. Put this into this array where this is point A and this is point B, and then build a spline out of that. But this being point A, it's going to do it over and over and over again for every single point. Okay. So that's that. And I'm sure you can probably imagine that there's a bunch of different effects that you could do with that. But the main thing to keep in mind here is that basically once you've got these points, regardless of where they come from, they're in this array. If it could be a piece of geometry, particles, matrix, whatever. Or actually, before I even move on, because you might have been thinking, what about a cloner? So I also want to show that just like we brought that matrix in, let's jump back before I deleted everything. So let's make a cloner and whatever, let's just give it some points and see, can we just drop that in the same way that we dropped in our matrix object. And as you can see, nothing's showing up. Let me just make sure that I am, yep, in here. So if we take the geometry, nothing's showing up. If we take the global matrix into here, we do get a line, but this is basically just the sort of like the pivot point of the cloner itself. It's not the clones. That's what we actually want. If we say the matrix, am I in the right thing? Yeah, okay. It's not showing up, nothing's happening. So that doesn't work. But what you can do is just drop the cloner in here as what's called a classic object. Then if you grab the matrix array and drag that in here, it's going to do an iterate collection, but you're going to see that nothing is still popping up. So the reason is something's got to be in the cloner. So it doesn't matter what it is. It can just be a null. And you see that as soon as we drop that null in there, then now we're getting our lines connecting to the cloner. So again, anything you can do, everything you would normally do with a cloner, this is all working with your node stuff. Okay? And the bigger point here, again, is just that once you've got these points in here, you can do stuff with them. So right now, I'm using them to build these curves, but you can do all sorts of stuff to them. So let's think about what else could you do. And it doesn't really matter where the points come from, but let's go ahead and just use these points. But instead of building an array and assembling a spline, I am going to, let's just make a cube. And I'm going to transform geometry. And in the transform, for this transform geometry, I'm just going to plug directly into this cloner and plug that in here. And so you can see we basically have got clones coming from nodes into the cloner. And basically we're just hijacking the matrix from the clone and using that. Now remember also that the matrix is not just the position, it's the position, rotation, and the scale. So if we go into this random and we also say we want a random rotation, that will work, and a random scale, that will also work. Now, you might be like, well, this seems like a bunch of weird stuff to be doing when you can already do this with the cloner just by dropping this right under the cloner. Okay, so let's do something else. So instead of doing this with this cube, let's make a text object. Let's delete you. And in this text object, I'm going to expose the text spline. And in here, I'm going to drop the index for this iterate collection. Remember, this is going to be well, you know what, you'll see. If we drop that in there, now you can see, let's go ahead, you get the idea with that. Let's just turn that off though. So now you can see, maybe let's chill this random position out. Maybe just turn it off actually. And if we go to our cloner, the cloner, and not that way, this way. Space this out a bit. All right, and we could do this if we wanted to have this in the right order. So now this is something that is not as easy to do just with the regular sort of cloner, is because we can have a variable input into what's being produced within seed nodes. So now we've got a different number for every single clone. Now this is just directly reading the index. This is all getting into, the stuff for the breakdown that we're going to do later. These are all the different pieces. So now we've got a number for every clone, but we could also remember that this iterate collection, what it is saying is for each thing in here. So we've got a matrix for every single clone. And so what's going to come out of here, we can look at it in here, is 225 different values. Or it's really do whatever you're going to do 225 times. Okay? So this hash node, this is the node to generate random values. And if we take the index out of here and we plug that into the seed, and let's take, I guess, just the integer out of here and put that, so maybe it is not the, oh, okay. So, and let's put the count into the maximum. So now we're saying generate, and you can see it here, 225 random numbers in between 0 and 225, which is the number of iterations. So now we made a random number generator. And you can see on the hash node, we can generate a random color alpha, a random color, a random integer, a random float, a random vector 3, a random vector 2, and a random boolean. So this is the random integer, but we could also say a random float, which is just going to give us a number with decimals. Okay. So that's cool. And the salt here is basically like a second seed, because we already used the seed to generate a different random number per iteration. But what if we want to now mix things up even more? So then you would adjust the salt. And so the salt is basically like our seed now. So you can generate new random numbers. But what else we can do is if we create a time node, and let's take our scene time and plug that into the salt. And that's too slow. So let's go ahead and just put the frame in here. And that's pretty fast. And you can do some math on this. So you could like take the frame and divide it by something so that you could get what do you call it, like a slower, things changing slower. Maybe we can do that really quick. So let's divide it by 2. So you can see we get things changing a bit slower. And that's cool. What else we can do? We can use noise and take our position here and drop that into here. And this is gonna, well, let's just show it actually. Oh, but then we've got to expose the time here. And in here, let's do the scene time. And we can adjust the scale. So this is just a different way to manipulate this also. It has a slightly different look. We can divide that one. And so you can see we can just generate a bunch of random numbers per iteration for this. All right. So again, the big takeaway here is you can get these points and then you can start to do stuff with them. All right. So, and we have talked about, so one of the things that we just did, the first thing that we did is we took one point and we connected that to a bunch of other points. So then we took all these points and we copied an object to all those points. And we took all those copies and we gave them a variable sort of value so that we've got a bunch of different things happening at all these points. So this is something that, again, it would be, I'm trying to think. I mean, I'm sure you could do it with like some espresso or something, but yeah, this is a bit different. This is kind of something that just in the normal, just dropping something into a cloner might be kind of hard. I originally sort of made this because on a job, I just needed to make like a numbered list, but it had like a lot of numbers. And as I was thinking about how to do that, I was like, I really don't want to just have a cloner with like 100 different text objects in it. I was like, there's gotta be. I was like, this seems like a job that scene nodes can handle pretty easily, which it could. Um, so yeah, we can do some fun stuff with numbers, and yeah, you can do some cool FUI stuff with that, with just like with numbers, just kind of constantly changing over time. So that's one little application. All right, so all that's cool. Let's get rid of a bunch of this stuff. Maybe I might just want to start a new scene, but let's just get rid of everything for a second. Let's come back in here, make another object group, and we will get some points from another source. So let's make a distribution within here. And so this distribution, you can see it's a 10 by 10 by 10 grid. Let's just say we got 1 in Y. So it's a 10 by 10, basically. And if we want to see this, so I've got a node that I've made. It's just called position to points. And we will, so this is actually a good time to talk about this also. So you see we've got this blue for array, and that's basically what's called a container. And that means that this is an array that contains a bunch of other arrays. And when you have one of these, in the same way that the different things inside of an array are called elements, and you can access individual things in an array by using a get element node. So you can see it says what's the array and what's the index. So that's basically, it's here's the array, and then the element in here would just be the one of these guys. It would be like 3 to get what's in bucket 3. Cool. So when you have a collection, the things inside here are called members. So all the different arrays in here are called members. So you could also do a get member. And so then it's going to say, well, okay, we'll plug in the collection. Make sure it's in index mode. Plug in a collection. And you can see that member 0 is the matrix from here. Member number 1 is gray. That's integers. Remember, this is another vector array. This is this yellow, that's a color array. So anyway, we can access the individual members here, or we can just say, let me see everything that's in here with a decompose container. So when you put this in here, then you can just see all the arrays that are in there. So we've got the matrix, index, source index ratio, and color. All right, so let's just put this into here and put this here. And you can just see that we've got these points. This node that I made, this is just, again, this is something that, this is nothing fancy at all. Just like a couple of nodes in here. Just this, but this is something, why make two nodes when you can just make one node? So I will go through a lot just to save myself a few clicks. So it's just these two nodes in here. But anyway, so that's what we've got out of here. We've just got these points. Cool. So what else can we do with these points? So let's say I just wanted to add some, like a y value. Like I wanted to lift these up and put them over to the side. Okay, so let's see how we can do that. So we've got this matrix. Well, all I really want to affect is the position. So the position is one of the vectors in this matrix. So we can do a decompose matrix. So that says put this matrix in here. And it's a bunch of matrices, obviously. So it's going to do this for all of them. Again, that's what the iterate collection is doing. Excuse me. So now we've got just the position right here. So one of the things that you're probably going to want to do as you're, well, actually, let's not get to that yet. All right, so we got all these positions. Now let's just say add. And let's add a vector. So I'm going to put this in here. And then we're going to add some in the y and maybe some in x, like that. So now how can we use this? Well, we can assemble another spline. So let's do an assemble spline. Now this spline is expecting an array. So that means that we need to collect these points and put them back into an array. So if you remember, I talked earlier about the recipe that we need when we did that build collection, that build array, and then we made those lines. The recipe was we needed the points and then we needed the point order. All right, so here what we've got is we've got sort of like our point A coming out of here, and then we added to every single one of these points. So the value coming out of here is basically point B if we wanted to have each one of these guys connect to each other. So to put this all back into an array, we can use gotta press C first, assemble collection. And so it's wondering, well, what kind of array do you want to make? So I'm going to say this is going to be an array of vectors. And we can put that in here. And we're also going to put this in here. So now, basically, what we've just got our same array that came out of here. And we just collected it into a new array of vectors. So we'll call this one point A. So now you might be thinking that we would just do the same thing to point B, and we sort of do, but it's a little different. So we can take this and put this into here. Oh, wait a minute. I was trying to do this the wrong way first. But I think I accidentally did it the right way. Let's see. So let's do another build array. And this is going to be an array of vectors with these two elements. Ah, okay, right. So, cool. So, right. If we, okay, yeah, that's right. I just remembered now what I'm doing. So we're going to put this here. All right, so it's going to say for every point in point A, this is actually point B. So yeah, I can still do it wrong. And then we're going to take this one and put it in here. And this is going to iterate through point B. So this is kind of a gotcha, because you might be thinking, okay, yeah, so we go through all these points, we go through all these points, we put that into an array. Now let me just, how many points did I have? Just so that this doesn't get too nuts, I'm just going to bring this down to 4 and 4. Okay, so if we then take this and do an assemble spline and do that, we are going to get this, which is not maybe not what you were expecting. So what's happening here is when we are saying for every point, because this iterate collection is basically saying for every point in this point A group, connect it to, it's not just saying connect it to point B, because point B is also a bunch of points. What we want to say, the logic of what we want to say, is connect every point in point A to its corresponding point in the point B group, which is just the offset point. But what we're actually saying with this pattern is for every point in point A, connect it to every single point in point B, which is not what we want to do. So instead of having this iteration, having an iteration for each one of these, you need to do a get element for this array. And so which index do you want to get the element for? Because we just saw that you can use get element, and then you can say, get element 0, or like if we just connected this and we said get element 0. Okay, well then we got element 0, element 1, 2, 3. So you can see we can get each individual element, but we don't want the elements one by one. We want all of them. So we take the index from the iterate collection, and we plug that into there. And that's how we get every point in point A connecting to every point in point B. And you can see what we've got going on there. So dealing with this was, ultimately other people explained it to me, Dominic in this case, just kind of explaining to me, this is how you set this up, because there was a night when I was sitting for a very long time trying to get something like this to work. Basically, I had points in one array and I wanted to do something with those points, and I was getting something similar to what I just showed you earlier, which is probably something you're gonna run into if you are just getting started with this stuff like I am. But hopefully you watch this video and you don't have to go through that pain that I went through troubleshooting to try and figure this out. This is the answer. This is how you do it. All right. So I think that's because I don't want, I mean, that might already be a little bit of an overload, but that's enough for this, for just the basics and explanation of dealing with and getting started with arrays. So now let's jump back here and let's look at how we do some of this. So first off, I'm going to, because some of this stuff, like I said, is just normal MoGraph stuff. So what we've got, so first off, we've got a similar setup to what I showed you. We are bringing a cloner in here, and we're taking the matrix from the cloner. Within that cloner, I just, instead of a null, I've actually got a sphere because I just wanted to actually have a sphere there. So that's coming in. We're iterating across those. And then I built a few different setups that I could switch between. So this is the setup for counting numbers. This is the setup for random numbers that I showed earlier. And that's the similar setup with just using noise to animate the random numbers instead of the random. That's all feeding into a text, and then this is just all the different parts of the text object exposed on the object. All right, so then that gets plugged into this transform geometry, and that's what moves each text object to a point from the cloner. After that, I then offset the text. So it's not, because this sphere is actually the point. But you can see that this is offset a little bit. This is exposed like this because at first I was just going to have this same offset control this line, but I'd actually rather have it just controlled independently over here. But anyway, so we've got the text being offset from the original position, because again, like I said, once you've got those positions, you can do stuff with them. So we've got the position now, so now we can offset from that position. So then we now just take that, tessellate it, extrude it, and that's how we get the numbers here as geometry. But since, again, we are getting the full matrix from our cloner, so the cloner has a target effector on it. So the text always faces the camera because we have rotational information coming from the cloner. Okay, so that's within this matrix that we're plugging in here. So then I wanted these little lines coming from the original point, pointing up towards our text. And that was just the last thing that I just showed you in here. So that's this. Basically the same thing. So again, we take that original matrix, we iterate through that, we filter out just the position, and we collect those position vectors in a new array. So this is just saying, give me out of the whole matrix, just give me the positions. So we got point A. So then for every point in point A, we're going to take that and we're going to add this to it, this offset. So you can see if I move this, it's moving very slow. This is set to I guess this is moving at like a 0.01 increment. That's probably too low. But anyway, so that gets added to that vector, and then we then collect that into an array, and that's point B. So that first iteration happens, so that's saying add this to every single point, and then collect those new points, the new positions for each point, into a new array. So then we also iterate across all these points, and we're going to build an array. Or, well, basically we're building the two elements here, and those two elements are going to contain all the values from point A and point B, but we are driving the iteration of point, we're driving both iterations from this single iterate collection. Because if we had two iterate collections here, then every single point in point A is going to connect to every single point in point B. And again, the logic that we want is for every single point in point A to connect to its corresponding point in point B. And this is how you do that. You have a single iteration, and you take the index from that and use that as a get element. The way, if we look at the data inspector, this is another sort of gotcha. How this looks visually, it just looks like we have an array with 77 values. But that's actually not what's happening. What's happening here is that this is basically a 77 times loop. So it's basically saying, we're going to do this math thing 77 times. It's not just an array with a sort of like 0 through 76. So it's 77 loops. So here it's saying get index 0, then get index 1, then get index 2, all the way up to the last index. And we then build a new array with those two elements of all the values and use that to assemble a spline. Now, this whole thing here, this will work without these two nodes. But this is me basically trying to be good and follow the advice of my senseis, which is to, when you have a iteration that's opening up here, you want to close it off at some point. And the reason that I think we're doing this, I'm sure one of them will correct me in the comments if I'm wrong, so I'll try not to screw it up. But basically, when you do like more complicated setups, if you have open iterations, then you can end up in situations where you do something like what I showed when I did that thing the wrong way, where you're iterating somewhere unexpected or where you actually don't want to be iterating. So by closing off these iterations, it's just saying, hey, iterate through this, and now we're done with this iteration. Hey, iterate through this, and now we're done with this iteration. So that those loops have a clean open and a clean close, and then you can continue to build on your setup without worrying about somewhere down the line something iterating more than it should. I think that's how that works. Remember, I'm just like a few lessons ahead of anybody watching this. Okay, so then we have all that, put that into another array, and then we just plug, this is now an array of geometry, and we can just put that into a connect object, which basically merges all this into a single like spline. And then that just goes here into the geometry op, into the children's op, so that all this stuff can come out together. And that's basically it. So what's actually coming from the node asset here is just this text and this line, and not the sphere. The sphere is coming from here. So now all this other stuff. So since we've just got a normal cloner here, a normal cloner that's cloning this sphere, then this tracer is just reading the cloner, and it's set to connect all objects. All right, and then on the tracer, we have this catenary spline modifier, which is one of the scene nodes modifiers that I think this one is made by Rocket Lasso. And so then on that tracer line, we just drop that, and that gives them this little wobble or this little droop, which I thought looked cool. And then, yep, we just got a random effector just moving these points around. And as I said, we've got a target effector that is making it to where the text is always facing the camera. And that's that whole setup. Okay, so hopefully that wasn't too overwhelming, and hopefully I didn't make too many technical mistakes that, as I said, I'm sure somebody in the comments will correct me if I did, which I welcome, by the way. Like, please keep that's I want that. That's definitely helping me out. All the tips you guys are leaving and uh, checking my work, I appreciate it. Um, but yeah, so that's an introduction into working with arrays. And yeah, we'll leave this one here. I'm not gonna do a long ramble after the fact this time. So hopefully you learned something and you can make some sense out of that. And I'll see you guys in the next video.